Hey guys, in this video, we're going to be talking about, how can I say this? We're going to talk about documentation for the product development. And we're going to look at this SLS4ALL open source project. Well, not open source, sort of open source. I guess yes, according to the license, it is open source, non-commercial. Anyways, so we're going to talk briefly about the documentation they have here and uh, what my thoughts are on this documentation. So a couple things, right? So again, they're looking at, so here we're in the hardware product development page here, and basically they are at the so again, the what this SLS for all the Nova is at this prototype stage. So they did the prototype stage was the one to the left that we watched in that video, and the one to the right now is their kind of quote unquote open alpha, or maybe they direct jump to the beta. Obviously, whether it's an alpha or beta really depends on whether you're going to have another secondary version before you go into the final release version, right? But that's usually whether to tell whether it's alpha or beta is basically whether you plan on doing another one or not. So um, hopefully he does another one that he can clear this up, because right now he's going to get it in a lot of people's hands and they'll be able to provide feedback to him. So if we go look at basically alpha here, so system schematics, right? So he has that control flow chart for the software. He may have that electrical diagram. It looks like he has that. He has the schematics of all the electronics, fully commented program. And again, what I'm talking about here is basically what he makes available. Fully commented program. I don't know if I saw that. Any transparency data, he's keeping that to himself. Alpha model, we do have that. Alpha bomb, we'll talk about that. He does have that. Operating manual and other procedures. He has an operating manual, I believe. Obviously, manufacturing. He has a procedure on how to assembly instructions. So he has his manufacturing procedure documentation. Testing, we'll have to check. Control system safety documents. Don't know if he has this. And then obviously design FAMICA, safety FAMICA, and then market requirement sheet. Don't know about market requirement sheet and don't know about these two, but that would be cool if it's provided. There's not that much transparency. But out of all this, he has maybe 80 of these that he's released, 80%. So here is how he did his bill of materials. So this is kind of how I suggest bill of materials is to go through here and to be able to see the different lines and then the levels of, okay, is this a parent or is this a child? So basically you would have, generally how it works is you'll have a kit. So a kit will be like level 0, or first you would have like a parent. So this would be the parent, and then you can say like this is a Nova, version 1.0.1 assembly, right? Or MLO, master layout, or assembly, or whatever, right? And then you would have one would be all your kits. So you'd have a whole bunch of kits. Generally, everything is kitted, is how I suggest it being. So you have kits, and then you'll have inside the kits, you'll have like you'll have like components in here, right? And then generally, you won't have a kit inside of a kit. You'll just have that will just be in the parent, but you can do that if you want. You can have a kit inside of a kit if you want to. So the reason why we talk about kits is that a kit is a assembly of components, is a collection of components in order to assign different zones, so that it also makes it easier in the model, and it makes it so that you can take your model and convert it directly to your BOM. So you take your model hierarchy and that's your BOM. So that makes it very easy to have transparency between model and BOM. Also, it helps when you're doing assembly, because you can say, okay, in this next section, we're going to need, this, and this kit to be able to start building this. And then you can more easily organize what parts are where, and also it kind of makes sense. So you can say, oh, for example, for him, it's like, oh, this is the powder chamber kit. So everything in here is to build the chambers. Okay, here's electronics kit. Here's a lid kit or a hinge kit for the lid, or a leg kit, leg frame kit, or the lift assembly kit for the chamber body, things like this, right? And then you would have generally two different types, which is do you make it? Do you have an OEM make it? Is it an OEM part? So it's like off the shelf. So when you say make it, do you make the kit? Do you build the kit together, or do you make the assembly? So let's say you have like an inseparable assembly, which is something that is welded or has threaded inserts or something like that. So do you add those pieces, or do you have a supplier add those pieces? Right. So if you add those pieces, that would be a make type. So for example, generally the whole assembly is a make. So you have either, and then of course, as assuming you're making it in house. If you're not making it in house, then you buy it. You have a vendor make the whole thing for you, right? Or is it an OEM component? Can you just buy it off the shelf? Or the whole assembly or that part, you buy it directly. You send the model to a supplier and they make it, and when you get it, it's ready to go. Or again, like I said, the make is you send it to a supplier, they give you the components, and then you put the components together. So that's a make, right? Now, portions of each kit and each component could be like multiple of these. So for example, let's say your parent kit is a make, but then you have different components under there. One component is an OEM, one component is a buy, and one component is an inseparable assembly that you make, right? So things like that. So that's what those three things here mean, right? So let's go ahead and take a look here. I actually downloaded one of them onto the so now with this one, I'm not crazy about the setup, but he is doing basically what I was talking about, which is he is using the bomb from the model. He's using the hierarchy from the model to create the bomb, right? But I'm not crazy exactly how he separated the bomb and also how he kind of separates this. So it's cool that he has all the images of what it goes to, but it would be nice if you just had um, it'd be nice if you just had a whole list, very long Excel spreadsheet of all of the components. Otherwise, you have to download each separate piece, right? And then put it all together and then make sure that you have all the sheets and you've ordered everything. It's just the kind of layout doesn't really make sense to me. So, for example, I looked at this fasteners one and I downloaded it. Now here it is in Open Office Calc, which is basically Excel thing to open Excels. And basically here you can see kind of his way of doing his bomb. So here he has, of course, all of these are OEM make, OEM buy. So these are OEM components off the shelf. And so here he has, the quantity, the description. But it would be nice if he had like an example of, a McMaster part number. McMaster is the most common, place to buy hardware in, I think, the United States, or Granger's or something like that. But McMaster has got the best interface to navigate. So it'd be nice if it just had like a McMaster part number for reference, right? Or if you wanted to order off McMaster or whatever. But this guy's in the Czech Republic, he probably doesn't have a McMaster over there. But here, for example, he has, he has the AliExpress because he's asking for a custom dimensions. So this is a make component, or sorry, a buy component. So this is a buy component, and then all these other ones are OEMs, right? But you can see all these different ones, very, very nice and organized. It's sort of, okay, so it's basically matched on alphabetically. Yeah, alphabetically. So, well, but it could be that just the open office did it alphabetically. So this is an example of his bomb. So this would be massive if I can download everything at once, right? And also some of these, it has like different it's all kind of broken out into different areas. So you see here, there's like, can I open the whole Excel? No, I cannot. Interesting. So I can only open individual ones, I guess. And then here's all the license agreements and these things. So for example, like this one's very small. I don't know. Maybe it's just kind of difficult to be able to. I really would prefer that people and myself be able to download the whole entire bomb, even though it's very long. It could be a couple thousand lines long. Most modern, even open source Excel systems can handle that big of a bomb, right? And again, some machines I work on, like one of the products I'm working on now has got 8,400 components. Now you can make the bomb smaller by having the by being able to tier it. So another thing that you can do is you can have it tiered such that you can have things where you hit like a plus and it opens up. So you can have a top components. So you could have like a kit. So altogether you would have like 30 kits. Same thing as the one I'm talking about that I'm doing now. It has like 30 kits, but it has 8,500 components. So inside the kits, all those components are in there. So it would look just like this, right? And then I can go in and say, okay, I want to look at, the lift assembly or whatever. And I could hit the plus and then it would drop down all of these. I'll try to get an example of this kind of laddered bomb and also put an option here for that. So I'm not sure if it's even possible in Google Sheets, because the one that I'm building now um, is in Excel. In Excel, you can do it for sure. I know that 100%. Anyways, so that is the bomb, right? And again, it matches his 3D model here. It matches his 3D model. So if you go in here and you look at the hierarchy, I already opened this. I guess I didn't. So here he has this frame Mark 1.1. I don't know why he calls it frame, but this is kind of his parent. Well, actually, technically, this is his parent. This is his parent file, and then he has everything inside one kit, which is kind of weird. You would think that, I don't know if this was a mistake. These should all be on the same level here, right? So this would be like, these would be the different kits. So you see here, it's not made up of very many kits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 kits, right? And again, this doesn't have any cabling in it. There's no cabling at all. We saw the harnesses, but no cables. But just kind of strange how he does, like, all the screws are in its own set, which I've never seen done before. Generally, how I've done it in the past is have the screws be in whatever assembly it's supposed to be in. Because now, if we look in here, right? Okay, so they do have it. He does have it broken off into separate areas, but then why not just take this bottom frame and then find the bottom frame in here? I thought I saw a bottom frame. Wow, this one. It's not even a bottom frame here. It's in one of these other ones. Some of these are kind of weird. Like this one only has two parts in that one kit, right? You go in here, two bodies in one kit. So yeah, I mean, maybe I'll go through this. Maybe I'll go through his for future video. I'll go through his assembly here and reorganize it. Won't add or take away anything. I'll just go through and reorganize it, and then put in all new kits here to kind of put everything together. And I do kind of want to talk to this guy. I'm gonna reach out and see if he wanted to do interview or talk about some of this stuff, because again, I'm really into this type of thing, obviously. So Yeah, let's go ahead and so that's kind of how it is. And then if we go back, but yeah, you can see how the setup here is the bill of materials setup is similar to his CAD model. But yeah, just kind of weird. I'll go through and set up and maybe show kind of what the bill of materials would actually look like. Next one, he has a pretty cool assembly manual. I'm not sure if it's necessary, but we can take a look at it. So he has an interactive assembly manual. So this is pretty cool. Oh, and also it looks like it saved my progress. So you click on it and it says, okay, it's set up for 1920 by 1080, so 1080p. This is a 1440p screen that it's on right now. But this is pretty cool. You can step through and it talks about, I don't know why it says and so on and so on. I don't know what that means. Okay. Oh, I stepped to the end. That's why. It's this one is this is the next, yeah. So this is the next one. This is the jump to the end, step 2 of 40. So here's just talking about the key parts. This is pretty cool. And also this interactive, so you can rotate around without a CAD ball, except for this number 3 here is broken. But yeah, pretty cool. Makes it transparent. This website is https instructions.online. And it's got some pretty cool animations. You can go in here and look at, okay, what is this thing supposed to look like? And hit the next button. And you can see it like assemble. And it's talking about here Loctite 243. And then it's got his the assembly instruction version number, and SLS4ALL here. It's pretty cool. So you can get color, and it looks pretty cool. I'm not sure if you can like just import a step file and then already do these exploded drawings, or you have to do it inside. I'll have to check this out because yeah, this is pretty cool. I was looking at this yesterday. So this is his assembly documentation, right? And this is pretty cool. Talking about inserting the T-nuts into the assembly. And this could provide, if you have a pretty advanced assembly, this can provide quite a bit of extra detail on how things actually go together. Basically has built-in animations, but it makes, I think this is an addition because then, okay, what if I can't watch this and build the thing at the same time, right? Um, what if I, wanted a printed version? So it'd be nice to also just have a printed version. Interesting. His wiper thing is just screwed on, so I don't see any. Interesting. So he doesn't have any locating. He's using flathead countersunk screws to basically locate. Interesting. So how does it keep pinching? How does it keep from pinching and these things? And it looks like this guy, the screw head will be inside. I saw some screw heads there. Yeah, pretty cool. I think this is just one specific instructions here, which is interesting. But yeah, pretty cool. So this is basically his assembly manual, right? I think it's I think he's just kind of started on it. So this is that same this one. Anyways, so I wanted to go further into kind of everything that he was supplying, right? Oh, so he does have GitHub. So yeah, it looks like he has basically all of everything is open here. So now that means going back here. So he does have, hopefully it's commented. I didn't look at it, but fully commented program, right? So he does also have that for a full, this one. It's got some high resolution photos, pretty good focus. Yep. All right, so I just want to do a quicker deep dive in here and kind of show my thoughts on how he knew that he was ready. Okay, so let's talk about that. So, how did he know that he was ready? So, here, required documents to reach gate 5. So, he ran some marathons of testing, right? So, we see that. We see some, prints here, whether or not he did an actual marathon. Again, I need to come up. I've been saying this for a couple times already, but I need to sit down and do it. But you need to come up with a number of tests that will be required to say, hey, this is an adequate number of runs to simulate kind of what I expect to have in a lifetime of this machine, right? And so that would be your marathon. And every time you make a change, generally you're going to want to do that marathon again um, to test that change. So hopefully he's done that, but that would be what we're talking about here for a marathon. So he has the fully commented program. He has the electrical diagrams. Oh, maybe he has a control flow chart, um, system schematics. Don't think that's really needed here. You're just going to have electrical diagram, right? Because here, system schematics is usually if like you have like some sort of air or hydraulic fluid or some sort of control fluid or water or whatever. If you have water flow, so if you have or gas flow. So if you have gas flow, you would have a schematic of how does this gas move around, or how does this, so whether you have a pneumatic or toxic gas, something like that, or fluids, hydraulic fluid, whatever, then you would need this system schematic would be ideal for this. So this you wouldn't really have in this case. So this is okay. Control flowchart would be pretty good to have in this situation because he does have electrical and software. So how do electrical to hardware interface? So how do they talk to each other? Right. He has the model. He's got the bomb ready. He's got the manual ready. He's got how to put it together. Um, he may obviously in that one he didn't have any of the manufacturing testing, so I think these are he's already working on. right? And then also here would be, okay, test to make sure that those two switches work. So that would be important. And then also these two, very, very important, the two main scorecards. And then of course, market requirement sheet. So I would say from this, he is, basically ready to go to a phase 5 exit, which means he's ready to either ship or in this case release open source his alpha. And that's assuming that he has good performance that meets his MRS market requirement sheet. So that's assuming that, and that's assuming he's done a lot of these fixes that we talked about in the last video, and that he has done all the marathons needed to make sure that customers don't have as many issues. So I'm gonna go ahead and reach out in the contact here tab and send him an email and see if we can talk further about this project. Pretty cool project. All right, and I'll see if he does reach out, or if I have some time, I will see if I can go back through and get into Fusion here and reorder kind of these kits, and then also kind of create a BOM example for this off of what he has. So let's go ahead and see if I can do that, so I can give some examples. All right, thanks, and I will see you guys in the next video. Later.